So for the remainder of the morning before lunch, we are going to have two panels. The first is on human-machine teaming and is going to be moderated by Dr. Jordan Krauser from Smith College.
Hi, I'm Jordan. I teach at Smith College. Many of you may not know about Smith, but we are an undergraduate institution in Northampton, Massachusetts. I'm lucky enough to have 5 of my undergrads joining me today. So I'm a little bit of an atypical moderator in that I'm coming from that perspective. So when they asked me to moderate this panel, they said, can you put up a definition of human-machine teaming? I'm not so good at definitions. I'm better at questions and big ideas. So instead, we're going to organize a little bit around that. So the first big idea that I want to throw out, which may not be new to a lot of you, but is this idea that humans and machines have complementary strengths, right? That when we think about computation, when we think about machine learning, when we think about artificial intelligence, we're often thinking about things like speed and scale or scalability and precision. Right? If you want something done precisely and to an exacting specification, you probably are falling on the machine side. But if we think about the human, if we think about the analyst, we're often thinking about perception and context and expertise and creativity, the ability to adapt to uncertain or changing environments. So these strengths can amplify one another, but they also present some unique challenges. And I think it's probably safe to say that the problems that most of us are worrying about, right? Things like, how do you keep airplanes from crashing into each other? Or how do you secure a power grid on a country that's the size of a continent? How do you detect fraudulent wire transactions when the bad guys are humans and they keep changing their tactics? How do you secure a network? Right? These questions, these big problems, they're requiring us to draw on strengths from both of these sides. So here's the rub. Traditional interfaces, right? I work in visual analytics. I work in data visualization largely. Traditional interfaces where we have an analyst sitting at a screen and they click some mouse buttons and they type some things are not very good at enabling effective collaboration between these two sides. So how do we integrate humans and machines in a way that their strengths complement and amplify one another? So that's sort of going to be our guiding question for today's panel. So I'm so pleased to have Kem Thompson, Celeste Paul, Chris Cook, and Samantha Simzak here with me today. I'll let them introduce themselves. I'm going to join the panel a little bit. This panel is designed to be interactive. So I have some questions that I'm going to ask, but I think, do we have mics for the audience? If you have a question, speak really loudly, and I will amplify your question into the. Oh, we do have a microphone. If you have a question that you want to ask of the panel, please do. All right, I'm going to come join. I'll turn off this mic so we don't get. Great, so I'm going to ask each of my panelists to just briefly introduce themselves.
I'm Ken Thompson. I'm a member of the LAS staff. All right, that sounds much better now. My name is Ken Thompson. I'm a member of the LAS staff. I've been here for a few years now. I'm currently the co-lead of the 2018 Collaborative Computing Exemplar. But prior to that, I was doing a lot of visualization research in a lab, specifically looking at what types of visualizations help which types of analysts with which sorts of tasks. And prior to coming to the LAS, I had worked as an analyst for a number of different organizations and a number of different capacities, doing a number of different things for, wow, over a decade. So, wow, I've been doing this for a while.
Hi, my name is Celeste Paul, and I'm a technical advisor and researcher in the Computer and Analytics Research Group. At NSA, I am also the technical director of cyber at the Department of Energy for the next 2 years. And so my background is in HCI. It's an equal part of computer science, psychology, and design. And I've really been focused on understanding how people interact with interactive complex systems to solve hard problems, especially when those systems might be smarter than they are.
Hi, I'm Chris Cook from Pacific Northwest National Laboratory. My background for the last 20 plus years has been in visual analytics, in trying to develop and innovate on techniques and approaches to allow people to gain insight in complex data sources, whether that's in information analysis or in emergency response, bioinformatics, and so forth. The key idea is bringing together key innovative analytics with visualization and interaction to allow people to interrogate their data and develop a hypothesis and test those hypotheses in their data.
Hello, my name is Samantha Simzak. I'm the Director of Cognitive Systems Engineering at Resilient Cognitive Solutions out of Pittsburgh. My education was in systems engineering, but I've been practicing cognitive systems engineering for the past 15 years. And my interest is really in building what we call joint cognitive systems. And those systems take into consideration the goals of the domain of the practitioners, the technologies that we're building, and our end users all together holistically. And how do you build systems that take each of those perspectives into consideration in the actual design?
Great, thank you. So, as you can tell from our lineup, we have really diverse backgrounds, and so we're coming at this problem with insights drawn from our respective domains. So I think I'd like to open by asking my panelists, what does it look like for humans and machines to team up in your world?
I'll kick that off. So for me, when I think about what it looks like for humans and machines to team up, it's a lot like what you described before. You know, I want a machine to be able to help analysts get from A to B, which is to find those gold nuggets of information. There's a lot of different tasks that analysts are responsible for doing that aren't necessarily analysis. Things like setting up queries, things like deciding the right workflows, things like doing visualizations or picking visualizations, as well as going through a variety of fairly complex workflows. And I think in some cases, machines can really help analysts do that. While at the same time, I want analysts to spend and focus most of their time dealing with the task that I think analysts are really good at, which is dealing with ambiguous information. So in short, I would love when I think about what this looks like, it's one where the machines are essentially helping the analysts find those gold nuggets of information, finding that information, and then the analysts going through a manageable, or what we sometimes refer to as a human-manageable amount of data so that they can come to solid judgments so decision makers can make the most right decisions.
Organically jump in. So if you want to jump
So one example right now of human-machine collaboration I think of as something like the Active Data System, which involves supporting people in doing analysis on multi-type data. The idea behind it is that we infer based on what the user's interactions are. We try to infer what task the user might be working on. And from there, run different analytics in the back end to try and proactively look for patterns or look for things that might be relevant and interesting, and then recommend those to users to enrich their analysis. It's not an idea, the point of it is not to try and dominate or take over or automate the analysis so much as it is to enrich and support the discovery process and hopefully allow people to get into more data and test more things than they would be able to do individually.
But I agree with everything everyone has said, and I wanted to think of something I could say that's unique. And I think one thing to add to that is that, from the perspective that I come from, is not to build black boxes where these things go out and do these underlying tasks on the analyst's behalf without the analyst really understanding what it is that the technologies are doing. And so I think if you ask what is human-machine teaming, from my perspective, it's also including that communication factor between the machine and the human, so that the human knows when the automation is struggling, so the human knows if the automation is up to date or if it's still churning in the background. And I think that then becomes a key component of what people think of as trust.
So I clearly drew the short stick going last here. So I think when Jordan opened up with what the strengths of machines are versus humans, that's how I view what it is that we're aiming for. And we already do this with computing systems now. Whenever we develop analytics, we try to figure out what questions that the computer is better at answering versus the human, leave the human tasks to the human, so that we optimize both the computer's time and the human's time. And I think sometimes whenever we start talking about human-machine teaming, it elicits an idea of what it is that we want or expect for the future. But I would argue that we're already on our way there. It's just that our successes have been so well accepted that the existing teaming is already invisible. And maybe all we need to do is to continue down that path.
I'm gonna go out of order, and I'm gonna ask a question that I didn't prep my panelists for. So we'll see how this goes. So many of us have been working in this area for a while. What would you say are some of the biggest misconceptions about human-machine teaming?
So that's a really interesting question. And I know from the analyst community, let me rephrase that, because that's a little too holistic. From the analysts that I have had conversations with about human-machine teaming, human-machine collaboration, the overall machine learning, AI, research that's going on, a lot of analysts will sometimes flat out say that they're afraid that this is going to do their job. And I think one of the misconceptions is that this sort of technology can replace a human. And I think that's something that has to be, I think that's a misconception that some analysts have. I also think that's a misconception that some researchers have, where they think, yeah, if I understand what the human does, if I understand that well enough, I can develop a technology that can replace all these humans. And I think that is a misconception. In a way, it can be a dangerous misconception, because I think what it can result in is people doing work, investing a lot of time and resources in a research effort that isn't really going to necessarily bear fruit.
Yeah, and along those lines, Ken did a good job of describing that fear of replacement that pop science discussions of artificial intelligence is kind of instilled on the workforce. And I think part of that we fall into a trap of as researchers is we're thinking about artificial intelligence. We start to try to create artificial humans, and our AI research kind of started as trying to mimic or simulate human thinking. That didn't work out so well, so we realized that maybe computers should do computer-like thinking. But even now, with discussions amongst my peers here, because we've all been working on this topic for at least the past 2 years, is we struggle between, are we trying to make a human-like machine, or are we really trying to take advantage of the strengths of the machine in a human-like way? And as researchers, we take inspiration from other areas of research. So for example, in psychology, we have these mental models or psychological models of how people actually work through processes, so in cognitive psychology, and we try to mimic that in the computer. But that is, again, getting back to, we're trying to create an artificial human, and is that really the right type of partner that we need whenever we're working in these complex analytic environments, when really what we need are analytics that are aware or have empathy is a human trait, but are empathetic or have context of the human, but don't try to be the human.
So I think one of the misconceptions or one of the challenges is that as we started this off, we didn't start with a formal definition of what is human-machine teaming. Until we can articulate explicitly what it is we mean, we're going to be open to all kinds of misinterpretation and miscommunication. So one of the important things, as Celeste was alluding to, mental models, common ground. How do we have a shared vocabulary about what we talk about? It's important that when we use the same words, we mean the same things, and that's a real starting point for making sure we're talking about the same things. The term human-machine teaming, at least as far back as I have seen, is deeply embedded in the DoD community in looking at very tactical tasks. And what we're talking about certainly in this community is work that is much more that of a knowledge worker rather than somebody who is flying an airplane. And so I wonder how we talk about human-machine teaming specifically in this group. Particularly, what is the difference between collaboration and teaming? If I think about my team, my multidisciplinary team of folks at the lab who are working on a problem with me, we have that effort to develop that common ground, develop that shared language and that shared understanding. And I think that's one of the real fundamentals that we need to get to in order to move in this direction.
Sorry, I don't mean to like bump in front of Sam here, but the common vocabulary is absolutely essential. I mean, that's essential for any good research. And I think we gravitate towards this, excuse me, this idea of teaming because human-human teaming has very specific properties that we can easily operationalize and develop prototypes for and evaluate to see whether or not we have an effect on the environment that we're studying. But again, using teaming as an inspiration, I think, is a great approach, but we've easily fallen into the trap of we're trying to mimic human-human teams in a human-machine way, and we're starting to realize that we're pulling in human traits that shouldn't be applied to a machine because machines just aren't good at those things. And so the vocabulary definitely helps and the inspiration certainly helps, but as this research area matures, I think we can start pulling away from these models that were giving us direction so that we can find our own way.
I'm gonna take the conversation a little bit different direction, kind of building on what Ken was saying earlier about the concern that we're replacing humans. I think we also need to kind of step back and really think if assigning a task that exists today to a computer is actually the right model of approaching teaming with automation. And what I've found in a couple of examples was that model wasn't really beneficial for anybody. And it kind of goes to your precision point earlier about algorithms are good at precision. What we're finding is that not all algorithms are good, have 100% hit rate, or they don't really produce the output that everybody would like if we're going to use it as a replacement for the human doing that same task. And so I think the misconception is that we need to find a task that the automation is good at, and that then presumes that there's a task that we do today that it's going to take over. And I think moving forward, a challenge that I think I would propose people should think about is how do you change the paradigm of how the human and the machine are going to work together, so to make it a little more tangible, rather than allowing that algorithm to do that task for the analyst or on the analyst's behalf. Could that algorithm run at scale and at speed as a tipping agent to draw the user's attention to things that might be interesting and useful. But there is no tipping agent role today, so that is not a task that exists that we're going to assign to the algorithm, but we need to sort of rethink the engagement of those two things.
I just want to say that there's some fantastic collective wisdom in the body of people I'm sitting up here with. Chris alluded to one ongoing project, an Active Data project. And I was wondering if there are other kind of concrete examples that the panel could give of some successful human-machine collaborations that you've worked on.
That would be hard for me because I've worked with Chris for the past 7 years, and so I think our successes are somewhat joint.
You don't have to be independent. I'll also open it up. So I'll make this a joint question. Yeah? Okay.
This is a variation of what you asked. So I think for human-machine teaming to work, analysts have to be, or humans have to be comfortable with a machine having more of a role than just a tool. And while I can't necessarily speak to a clear human-machine teaming success in the mission space because it's a relatively new field, but I think a lot of the advances that we have made in the field of analytics over the last 10 plus years have put analysts and humans in general, but analysts in particular, in a position where they are about ready for a human-machine teaming experience. And I think that's something that's really important because, I mean, we've all heard the cliche being ahead of your time. We don't want to have a technology that works and is functional, but the customer base, the users just simply aren't ready for it. And I think because we have made progress in the world of machine learning, we've made progress in the field of analytics, we've made progress in the field of recommendation systems, that humans now, analysts are ready for, or are about to be ready for a human-machine teaming system that engaged in certain activities with their own agency without having a human tell them explicitly what to do. And I think having to use a military term, having prepped the battlefield for that is a really critical objective.
But what does a human-machine team look like? And we missed kind of the definition earlier because none of us could probably really agree on it. And I would argue we already have some teaming in our environment. It's just that it's been so successful, we don't call it teaming anymore. So Clippy from the 90s was an utter disaster. But concepts from Clippy made it into Microsoft Office with auto grammar check and auto spell check. Is that not a form of teaming in some way? It's just that the interface doesn't have this anthropomorphized ideal to make it overt and obvious. And we use recommendations throughout the enterprise, at least for us. Mark loves the Clippy example. Can't make me laugh up here on stage. But we've been using recommender systems for nearly a decade. When we first introduced these ideas, they weren't so good, and so they were very overt. Oh, the recommender isn't working today, or oh, the computer's not feeling so well today. But now we've managed to tune them in such a way that people don't even realize that whenever they get results back from a query, they're ranked in some way, and they introduce like multiple analytics that have fed into these recommendations. Is that not the machine working with the human in providing some insight or some type of teaming?
Yeah, so I'll build off that. I agree with what Celeste is saying in terms of when you have a successful teaming with automation, it'll almost feel invisible. You'll just be working, and you'll just be working more effectively, and you won't even know that the automation is there. To give an example of where we saw this, we're working on the BEAST project here for the lab, and we had a workshop with some analysts in October. And one of the analysts stood up and said, I thought the system was going to automate analysis, but it's actually making me think more and be a better analyst. And I think that example really brought home the fact that we may have a good teaming with automation model built in the tool, because there's nearly 45 automated agents running in the background.
Yeah, the look of a successful human-machine teaming effort is that less burden is placed on the user to do stupid things or things that don't take advantage of their innate skills, their special skills. Things like grouping images can be automated really nicely right now through deep learning in a method that helps reduce the amount of effort a person has to go through. There's an example that I'm familiar with where a climate scientist at the lab was spent a lot of her day just marking the locations of clouds in imagery. And they were able to develop some deep learning algorithms to model the data and identify with some degree of precision the actual clouds in the data, reducing the need for her to spend this PhD's time on marking pixels on an image so that she could do more climate science. So these are the examples of things that help remove some of the burden off of people. But to your point of making somebody think more deeply or be a better analyst, that is kind of the idea, being able to take some of those more mechanical or rote things off of people's plates so that they can do the part of the job they actually were excited about in the first place.
So Celeste brought up Clippy. I love Clippy. I love it as an example. I don't actually love Clippy. But this draws our attention to the fact that failure is often a really integral step toward innovation. And so I was wondering if any of you have insights from projects either that didn't pan out or that went in unintended directions that you might be willing to share. They don't have to be your own examples. They can be others that you saw.
So it kind of goes along with what I was talking about earlier about changing the paradigm of how the user and the automation are going to actually work together. And we were brought onto a project where they were kind of like the example you were giving, where the computer vision analytics were looking for things in the imagery. And the interface that they gave the end user, who was an analyst who was supposed to use the output of these analytics to actually find things that were interesting, was essentially like a Google interface. And the analysts that were using it could barely find anything in the data that was useful. So it was a long list, and it, let's say it found people, so it said person 1, person 2, person 3, person 4, and it gave them no rhyme or reason to click on person 1 versus person 99, because the nature of the analytics were sort of generic. And so we had come in and sort of changed the paradigm on that and said, rather than having the analyst search either for arbitrary things or have to know what to search for before they even know it's in the database, which is kind of a conundrum. We put a different kind of user interface on the display that exposed all of the findings of all the analytics in multiple different frames of reference. There's a time-based, geo-based, and then it exposed the actual findings themselves in sort of a meta-content kind of way. And we actually found that when we connected it to their database that they were demoing with, they were saying that they were demoing 10,000 hours of video, but they were only demoing 4 minutes because they were so overwhelmed with data overload by the presentation of the analytic output that they didn't even realize what their data holdings had.
Chris's example of clustering of objects and the role of machine learning or even semi-supervised machine learning is probably a good example of this already. It cuts down on incredible amounts of manual work and time, but also gives the opportunity to refine as needed in order to establish that context.
One example I would give in terms of failure is not necessarily a failure of the software, the technique, but a failure of paying attention to users' needs to be able to get it adopted. This has been several years ago, but we had a really, really cool tool people were really excited about that helped people understand drug discovery data more straightforwardly, using visualization, using several other techniques. And when people who did this for a living got a hold of the software, their first observation was, where's my spreadsheet? You've given me all these great ways of looking at this data, but I have honed my skills over 20 years in finding patterns in spreadsheets, and I can visually pick out anomalies in spreadsheets, and that is my work process. So you haven't supported my work process. So understanding that people's work processes are not necessarily optimized, and you need to give them some bridge to get from existing approaches into using advanced techniques or new techniques of any kind, even if they're not particularly advanced. Building those bridges for people is equally as important as building software tools that work.
So both Samantha and Chris have talked about the importance of bringing in domain-specific considerations when we're designing visualizations and interaction techniques. But we also heard earlier today that our machine learning and other computational techniques are often still a black box. So do you have any thoughts about how to bring this same intentionality in terms of design to our decisions about the computational techniques that we bring into our systems?
Okay, I'll jump in. That's a really interesting and challenging problem. So right now, there's a lot of research going on funded by the government in explainable AI. How do we convey explanations to people that are easily interpreted to help them understand what's going on in that black box? I think there's real promise in some of the research that's going on there, but explanation is not the only thing we need to worry about. Celeste mentioned earlier trust. You know, as new models, as new techniques are made available to users, it's already hard enough to learn how to use all of the tools that you could potentially use. And then if you have a vast variety of analytic techniques you could apply, that just makes the problem harder. So I think this is a really tricky question and one of the areas that we need to do the most work on. One approach might be just as we've gone toward discoverability of data sources, is there a way of doing discoverability of analytics so that we can characterize where things should and shouldn't be used? And instead of just recommending data to people, recommending the right analytics that could be used for a particular situation.
Yeah, I think the XAI problem is both fascinating and really difficult to unpack because it's not just explaining how the machine got the answer. So that's a very end user focused problem, and we have a lot of processing that happens before then, right? So there's the actual design and training of the model, there's the implementation of the model in a greater analytic system, and we need to be able to expose those processes before you even get to the answer in an explainable way. And again, more work that I'm working on with Chris, and so maybe we don't have as diverse of opinions as Jordan was hoping. Using visualization in order to help explain not just the results of the model, but the provenance of the data and all of the analytics that fed into that endpoint, because really complex analytic systems have more than one analytic touching the data, right? So we're feeding in the results of multiple computations in order to achieve something that we couldn't easily achieve before, or that the human couldn't do on their own. And it's really easy to lose track of where that data came from, and did that process that the data come from, do we have trust in that analytic? Does it have some value associated with it? Was this a low confidence value that fed into a high confidence model, and we washed all of that out? And I think that's getting into the underlying technology that if we do our jobs right, users will never need to worry about. But as the researchers and the technologists who are actually developing these things, we need to keep them in mind.
I think it's also important to understand who the end users are and provide not just a one-size-fits-all approach to describing what the analytic has done, what data it used, how it found the data, how it processed that data, but realizing, understanding that, all right, I'm explaining this to an analyst, or I'm explaining this to an intelligence analyst, or I'm explaining this to a data scientist, because different communities, different types of people are going to process information in different ways. And I think understanding who the user is going to be really critical to ensuring that we don't have a black box system, to ensuring that the explanation that we provide, that the system provides, is one that's tailored to that end user, so they can explain to their customers how they came to their conclusion by describing the process that the system went through. And I think that's something that's really important. I also think in this day and age, because we're getting so much data on individual people and users, that we can probably start tailoring those sorts of responses to those people.
I just had one thing to add to the discussion. So you had brought up domains and black boxes. And the approach that we tend to take is that there's the core domain. So that's in this case, the intelligence community and what they're trying to accomplish. And so the main visualizations for that user should have domain frames of reference on them, things that analysts care about, things that analysts want to look at in what they're analyzing. I consider the technologies that we've embedded in the system as sort of a subdomain. So whatever methods you use to determine what the best visualizations are for the core work, then can you leverage those same methodologies, design methodologies, to then discover visualizations that help you understand that subdomain of the analytic itself?
Sorry. If I could jump in with just one example about reflecting on explanations. So I am been in this field in the visualization work for quite a while, and I've had opportunities earlier in my career to try to explain like clustering algorithms to people. And so you take data, you cluster it, you project it into 2 dimensions, and you present it as a scatter plot. Now, when people ask us, what do those axes mean? I could tell them that these are the first 2 principal components of based on a 200-dimensional vector representation that we've clustered. It doesn't mean anything to them. If they are mathematicians, they care. If they're not mathematicians, they care that it works, first of all, that it's been tested and proven. And second of all, they care about the metaphorical description, that imagine this is your desktop and you have grouped things based on similarity. So proximity means similarity. There's a mathematical explanation for it, but this is what you need from a practical perspective. And so thinking from based on Ken's comment, I think there's a real benefit to thinking about the different contexts in which we need to explain.
Yeah, so just to build off that, if you're going to present the output of the clustering algorithm, which is what you've described, I would then offer to also provide additional visualizations that then expose the performance of that algorithm and allow the analyst maybe we talk about observability and directability, but some directability of that algorithm as well. Because the minute you do that, then if the algorithm is outside of its comfort zone, or if it really didn't converge well on an answer, but it converged somewhat, then you can start to see those parameters, which are often built in as thresholds and are kept under the hood. But if you expose those things, then you start to help the analyst understand whether or not the algorithms are in its sweet spot. And that's kind of how you start to build that trust as well.
So I'm cognizant that there is another amazing panel right after us, so I'm going to ask my canonical closing question, my magic wand question. So you each have about 30 seconds, and I'm going to hand you a magic wand. And with that magic wand, you can solve one problem that you think is going to make solving all the rest of this stuff easier. We don't actually have a magic wand, but we have 300 people who I'm hoping are now convinced that they want to work on these issues. So what do you want them to solve?
I want to solve developing that common understanding so that analytics can, so we can do some things that automatically and proactively go off and automate particular analytics. Run some analytics, bring those recommendations back to users if they're meaningful, but have the computer system be much more able to be autonomous in running things it thinks will help the user. The user still stays in the center, but the system has a much better understanding of what needs to be done so it can bring forward the right analytic results.
So that was Chris's magic box of context and grounding. I would ask for my magic wand to give me a magic box full of models of people and how they think and what they want that never expire, because that's probably the #1 challenge that we have in automation and any type of teaming right now. We have to operationalize it somehow, and we need to give the machine all of the possible answers. And so we go out and do very expensive research in order to figure out exactly what all of those possible answers are. And by the time we operationalize it, those models are out of date and we need to start over. And I think that's probably one of the biggest reasons why we haven't gotten as far as we think we should have in human-machine teaming, because of these models, and we haven't really developed any good solutions in how to naturalistically pull them from the environment without having to actually go out and study them in depth.
And for me, it's how do you determine automatically when the data is good and when it's actionable? Because I think one of the challenges we have is, analysts that go through their tasks, that find information, it goes out and it's disseminated and then it's used. But when you're asking someone, okay, well, how good was that data? It's sometimes hard to describe. But if you automate that process, then I imagine a system could look at the data that an analyst may potentially analyze and rack and stack that, triage that, say this is the most important data because this sort of information is definitely going to be of use to these end users. So some way to automate the process of predicting and knowing what data is good and what data is actionable and useful.
So my hope for the community is that we shift the conversation from role allocation and role assignment, or at least start talking more about changing roles and transforming roles to result in that better joint solution in the end.
Join me in thanking our amazing panelists.
So we're going to take just a minute, and we will get our second panel on advancing the science of analysis up here to the stage. And thank you all very much. So our second